In this video, we'll be going over how to define sensors and their fields of view in SPICE and add instrument frustum models to the Cosmographia visualizations. First, we need to start out by defining the spacecraft sensor in SPICE via a text instrument kernel. We begin by assigning a SPICE ID to the instrument and giving it a string name, same as when defining a reference frame. Then we state that we want the sensor's field of view reference frame to align with the spacecraft body frame. And the simplest way to define a field of view is using a circle and a half angle, so that's what we use here. And then we define the bore site, which is a vector that the center is pointed towards. And in this case, we have the vector pointed in the direction of the spacecraft body x-axis. Next, we define the field of view size. So we use a vector that is perpendicular to the bore site vector to define the plane which the half angle will be defined in. And here we use the y-axis, but the z-axis would also work. Then we give the field of view a 1 degree half angle and specify that the angle units are in degrees. And since this field of view is circular, we don't need to define the cross angle. And here's a diagram of this scenario with the bore site vector here and the half angle. For reference, there are a few conventions that we use here that are recommended for convenience, like the bore site vector being aligned with a body reference frame axis, but aren't always true when defining more complex field of views like off-axis bore sites or trapezoidal shapes. Now we have to define the sensor in the spacecraft catalog. So it is of class sensor. We give it a name that we can use it by in the Python script, state that its parent and its center is a spacecraft we defined above, and we don't need a start time since it will use the parent's time. The geometry is coming from SPICE, and we use the SPICE ID that we gave the instrument in the instrument kernel. Earth is the target, range is set to a value larger than the altitude. There's a color and opacity, and we'll get to the footprint opacity in the next video. And for side divisions, when we use 1, Cosmographia will make the frustum a square, as we saw in the scene. But since we define the field of view to be a circle, if we use a higher number, like 20, the frustum will be circular shaped in the scene. And we'll get to the only visible during OBS in the next video. Then we have to make sure that we add the SPICE kernel to the SPICE catalog here at the bottom. And as far as the Python script, in this video, it was more so just trial and error as to getting the timing of when to show the instrument and when not to. But in the next video, we'll go over observations when we can set that only visible during observation value to be true, and we don't have to worry about the timing of showing the actual frustum in the scene. So that's it for this video, and in the next one, we'll be going over how to add observations to the target body surface as in this scene in order to get better visualizations of passes and demonstrate global coverage.